everybody. Welcome back to math class for Math 95. I'm excited that we can be back together and be learning some things again, and I hope you and your families are safe and healthy. And as I've said before, please just make sure that you're in touch with me about what is and isn't working. I'm trying to figure things out as we go. So I think I have things set up in a way that will accommodate a lot of people's changing schedules and family situations, but you just need to be communicating with me and let me know. All right? Okay, so hopefully you got my emails with the to-do list for this week, and you saw that there were guided notes I had attached to the email, and I also have them on Lumen under the Chapter 5 notes. So I'm going to have a series of short-ish videos, maybe 5 to 10 minutes, going through those notes little by little. There'll be places where I'll say, okay, pause the video, try this on your own. Then when you come back to the video, you can check your answers. In addition, as I said on some of the information, in the Zoom classes on Tuesdays and Thursdays, we'll be going over some of this. So what I would hope that you would do is try it on your own, and then when you come to the Zoom sessions, we can answer any questions that you have at that point. But try to do it on your own, kind of work through it and be familiar with it to see what questions you do have. All right, so let's go ahead and start. So I'm in the guided notes right at the top of page 1, and we talked about in chapter 5 we were solving equations, and in chapter 4 we were solving equations, and in chapter 3. In chapter 5 now we're going to be graphing those equations. So a graph, when we think about a graph on a grid like the one you see here at the bottom, when we have a graph on there, that's going to actually be a visual representation of some kind of an equation. So there's going to be a relationship there that we're going to see as we go through this. We had talked about before how we can't solve an equation if there are two variables. That's why we needed those systems of equations sometimes when we were when we were solving in chapter 4, we needed two equations sometimes when we had two unknowns. So if we had an equation, you can see on there, that's x plus y equals 6. This has two equations, two things that are unknown. I'm trying to get this glare off there a little bit. So x plus y equals 6. We don't know for sure what x and y are. There are actually a lot of different choices that x and y could be. So you can see some of those in that table there below. If x were 2 and I wanted 2 plus something else to add up to 6, well then this would have to be 4. So that's one option. Another option is if x were 6, then y would have to be 0 in order for those two to add up to 6. We could have negative 10. If I have negative 10, I would need to have 16 added to that to be 6. And if x were 3.5, then I would have to have 2.5 in order to be 6. So any of these is a solution to this equation. We don't have just one solution. We can't just say x has to be this and y has to be this, because there are lots of different solutions here. So the question number 1 says, do you think these 4 are the only solutions to this equation? Another way to think about that is, can you think about any other pair of numbers that would make this true? So hopefully you did, right? For example, we could have 1 and 5. We could have, instead of x being 2 and y being 4, we could have x be 4 and y be 2. That's another different set. So in number 1, these are not the only solutions to this equation. And so number 2, how many solutions do you think there are? Well, think about it this way. So if we can pick any number we want for x, and we saw that we could have positives, we could have negatives, we could have a decimal. So if we think about, if we can pick any number in the whole world for x, how many does that give us? Well, there's an infinite number of options for x. And then all we have to do is figure out what number would add with that x value to make 6, and that gives us our y. So in number 2, there are actually an infinite number of solutions to this equation, to an equation with two unknowns here. Okay, so when we show all of these different possibilities visually, then that is how we get a graph of an equation. Okay, a graph is like a picture showing anywhere on that line shows us a solution to this equation. So we'll get into that a little more as we get into graphing. But first, let's just look at graphs in general and kind of refresh our memory about it. So you have it there at the bottom of page 1. You have a graph. I have a little bit larger one here. So we call this setup a coordinate system, a coordinate grid, a Cartesian coordinate system, all those different options for names for it. Okay, so when we look at this, we can see that it's really just made up of 2 number lines. There's one number line going this way, like we're used to, and then up and down here is really just another number line. Okay, so in each case, one side of the number line is positive and one side is negative. Here in this number line also, the top part is positive, the bottom part is negative. I want to flip my notes here, make sure I'm not forgetting anything. So this, we call these each an axis. The axis going this way, you might remember, is called the x-axis. And the axis, or the number line going up and down, is called the y-axis. And when we put those 2 axes together, what that does is it means that any spot anywhere in space here has a name, right? And it has a location. So if I look at this point right here, that point has a name, and its name is going to have 2 parts. Its name is going to be how far over we went and how far up we went. If you've ever played the game Battleship, this might kind of remind you of that. On Battleship, you only have this part of your graph, and one direction is letters and one is numbers. You might have like B5, but if we had been able to do this chapter in class, we actually would have done some Battleship just as a way to practice our graphing a little bit. Okay, so in your notes, the example I have is the point 4, -3. Okay, so let me just write this here so we see it. It's in front of you there. So 4, -3. Okay, so the first point, the first number in this location is my x, is how I move along the x-axis. And the second number in my location is how I move along the y-axis. So I always start right here in the middle. We'll talk about that more in a minute. And this tells me where to move. This x is +4, so that means I'm going to move 4 in the positive direction, or 4 to the right. Now when I'm graphing, I leave my pencil, or my finger in this case, right there on the 4. I don't write anything yet, because I still have to do the y value. So my y value here is -3. That tells me how to move out along the y-axis. I'm here at +4 on the x. -3 means I'm going down. So 1, 2, 3, that's where I'm going to put my point. Okay, and we always want to label our points, so it doesn't really get labeled up here, right? This is just where I wrote it so we could see it. But I will label it right down here at that point. Oops, there we go. Okay, now when you're graphing, for some reason when people go down, they tend to want to skip this first line right here. I think it's because the numbers are there, so just make sure you're counting carefully when you graph. All right. So if you have the notes printed out, on page 2, you can put that point 4, -3 on that grid. Okay, if you don't have the notes printed out, just draw yourself a little grid, just sketch it. You don't even have to do all the lines going the whole way, but you can just kind of do your axes, and then you can just put the dashes here. And we always want to label at least a little bit. We don't have to label every single one, but otherwise I don't know if you're counting by 1s or 2s or 5s. So you want to at least label a few in each direction. Even if I'm counting by 1s, I tend to just label every other one, just so it's not so crowded. Okay, so if you don't have the notes printed out, you can just do something like that in your paper. So we had talked a little bit about this middle point where the x and the y-axis meet, and we call this the origin. Let's see, it's hard to do this upside down. Right there, this point right here is our origin. So I want you to think for a minute about what the ordered pair of the origin is. how far over do I move on the x-axis and how far up or down do I move on the y-axis. Okay, so once you think about that, you can put it in number 3 there, and then it asks you to graph it and to label it. So if you need a little more time, you can pause the video. Otherwise, if you said that the origin had an ordered pair, a coordinate of 0, 0, you are correct. We don't move left or right at all, and we don't move up and down at all. So that's what we call the origin. And as you saw, that's our starting point every time we're going to graph another point. Okay, so at the bottom of page 2 of your notes, you see some steps to remind you about graphing. So you want to start at the origin every time, and then you're going to use that x coordinate to go either left or right, depending on if it's negative or positive. Leave your pencil there, and then do the y value from here, either up or down, depending on if it's positive or negative, and then that's where you draw your point. For the points that we're doing here, you can label them by letter. So if you graph one, instead of putting in the coordinates, you can just say, oh, that was point A. So there are 6 points there. So you can go ahead and graph each of those on the graph on page 2. So you can kind of flip over to page 3, get the coordinate, graph it on page 2. All right, so I'm actually going to stop here for right now in this video because I'm already over 11 minutes. It's kind of long. So you can take a few minutes to fill in those 6 points on your graph. And then in the next video, we'll pick up right there at the top of page 3. We'll look back at the chart on page 2. That's where you'll have graphed them. But we'll look at those examples. And then we'll move on, going back to our equation of x plus y equals 6 to see how to graph that equation. All right, so go ahead and work on those 6, and when you're ready, you can start the next video. Thank you.